Okay, today we're going to learn how to solve a quadratic equation by graphing, which is what we did last class. But today we're going to add in identifying the domain and range and what is a parent graph. So we're still going to talk about everything we did last class and add one or two things onto it. Let's talk about some of the vocabulary first. First of all, we still have our quadratic equation. It's still in the form of ax squared plus bx plus c equaling 0. All your equations need to equal 0, so make sure they do. Most of them do, but you need to make sure they do. The roots are my solutions to the quadratic equation. Just like the first day, you find these by factoring or the quadratic formula. Now, if you remember from last class, that also is how I found my x-intercept. It is the same thing. They all lie in the same place. They're all solutions to my graph because my graph is x equal. X-intercept is x equal, and so are my roots is x equal. So my solutions are x equal, so they're all the same thing. Zeros are my x-intercept of the graph. So therefore, the x-intercept, the zeros, and the roots should all be the same answer. They all mean the same thing. It just depends on what you're looking for, determines on which vocabulary you use to find it. The domain is the set of my x values. For what we are doing right now, because we only have y equals equations, it's going to be all real numbers for our equations. When you get into Algebra 2, that changes, but right now, because all of our equations are going to be y equals, they're all real numbers because our graphs make u's that go up, 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 up forever and spread out, or go down, 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 down forever and spread out. So it's all real numbers for our x values. Our range, just like before, is the set of y values. This differs because it's only the part of the graph from my vertex y value up or down, depending on the equation we have at hand. So it's going to look a little bit different, and it's going to be an inequality, and we'll talk about that when we get to there. So let's start graphing. For our first example, we're going to start off the same way we did everything before. So the first thing we need to do is find our axis of symmetry. Axis of symmetry, just like before, is x equals negative b over 2a. Remember, the a, b, and c come from inside my equation, so it's negative 12 for my b over 2 times 1, so it's 6. Remember, it is an equation. X equals 6. It is not the number 6. It is an equation. It is an imaginary line that we make that is a reflection line for our graph. So at 6, we need to go ahead and make our imaginary little reflection line. Now we'll look at our vertex. Second thing. Using the value we just found for x, so our vertex is going to be 6 and then something, we're going to plug that x into x in our equation, and then we're going to find the y. Now, our equation looks a little weird. It says equal to 0. It's the same thing as equals y. It's just a different way to write a quadratic equation. It's the same thing as saying x squared minus 12x plus 36 equals y. Same thing as if it equaled f of x. They're all the same thing. They just look funny depending on what we are doing. So now, to go ahead and find my vertex, I'm going to plug in 6. And when I solve my equation, 0 equals y, so my vertex is 6, 0. Now I need to determine whether my graph is a minimum or a maximum. It's a minimum because my a is positive. Just got to look at the coefficient on a. So now the fourth thing, my x-intercept, just like before. I have a quadratic equation. I can either factor or use the quadratic formula to solve it. I'm going to go ahead and use my factoring. Make my chart. Find my two pieces. I'm using my shortcut. Now, just like before, each piece gets set to equal to 0. Solve for x. Now, x is the same for both of them, so that's fine. My x-intercept is just 6, 0. This is the part that we were talking about earlier. My zeros is also, my 0 is my x-intercept, so it is also 6. And I don't know if it needs to be in set notation or not. I would assume it does, but I'm not sure. I'll look that up. Here, my roots, same thing. It does need to be in set notation because it is a solution to my equation. So x equals 6. So right away, I can fill in those 3 spots just by finding my x-intercept because they're all the same thing depending on the situation. My y-intercept. We learned yesterday by graphing that it actually is just the constant in my equation, but to find any y-intercept, you set x equal to 0 and solve. So here, y is 36. Now, obviously, my x is 0, my y is 36. It'll be off my graph. I won't be able to use it. So I'm going to have to actually pick probably a point to graph. So let's go ahead and let me graph. I forgot to graph my x-intercept, which is also my vertex. So it's right there. I don't have any other points. I'm going to have to find some now. That's when we talked about the other day, making a little chart. If I make a little chart for my x and a y value, and I pick a number that's close to 6, like 5, I can find what my y is when I shove 5 into my equation. I'm just going to scoot this over so you can see it. So if I shove 5 into my equation, I end up getting, well, that's a y as well. So I end up getting for my y value 1. That's a point I can use, 5, 1, because I need something to make a u. Reflect that point because we reflect anything we can. I'm going to pick the next point over. So 4 squared minus 12 times 4 plus 36 equals y. So here, y equals 4. So I can take the point 4, 1, 2, 3, 4, and reflect it. Now I can make a nice pretty u. Sometimes you're going to have to make a table. Not often, because usually once we find our x-intercept, once we find our y-intercept, and once we find our vertex and we reflect anything we can, typically we have our 5 points for our graph. So now back to our domain and range. Our domain, we said, is our set of x's. Our x is going to get bigger and bigger and bigger, so it's always all real numbers. But now we're going to get to our range. Our range is the weird one. It's the set of y such that y has some relationship that's going on. From the vertex, I have graphed everything above it. My vertex y is 6. Because everything above it is graphed, it's everything greater than or equal to that 6 is part of my graph. Nothing down here that's less because my graph doesn't go this way. Let me repeat that for the range. It's the set of y such that y is everything greater than the y value in my vertex. Let's look at number 2. First thing I'm going to do, find my axis of symmetry. Well, Miss Singletary did that wrong, so let's go back and change that. It's negative 6 over 4, which equals negative 3 halves. Now, somebody asked me earlier, can you leave it as a fraction or can it be a decimal? It does not really matter for the graphing purposes, as long as it's not some funky-do fraction that makes some weird old decimal. As long as it's a nice clean decimal, you can make it a decimal. My axis of symmetry is an equation, so I'm going to write it as an equation. 3 halves is negative 1 1/2, so I'm going to go ahead and make my axis of symmetry over here. All right, to find my vertex, plug in my axis of symmetry is x. And when I plug it all in and I get my answer, I actually get negative 12.5 equals my y value. So my vertex is my x, which is negative 3/2, and my y, 12.5, negative 12.5. Do I have a max or a min? Well, I have a positive coefficient on my a, so it's a minimum. Plugging right along, and my x-intercept. That's setting my y equal to 0, which it already is in the equation. Now, because I've got a bunch of even numbers here, I'm going to GCF out a 2 to make my life easier. I need to go ahead and make my table of values. So I have what? Negative 4x squared to give me 3x. Positive 4, negative 1 gives me positive 3. Take my shortcut, x plus 4, x minus 1. Set each piece equal to 0. I did not set 2 equal to 0 only because it's a number, and a number can't equal 0. It doesn't make sense. So I have x equals negative 4 and x equals positive 1. That's my x-intercept. Negative 4, 0, positive 1, 0. Again, coming straight down, my zeros are negative 4, 1. My roots, negative 4, 1. And again, I don't know if the zeros have to be in set notation, but I'm just throwing them in there. The roots have to be. All right, my y-intercept. As we learned earlier, it's basically my constant. So 2 times 0 squared plus 6 times 0 minus 8. So my y-intercept is going to equal negative 8. Domain, all real numbers. And again, I made the rookie mistake of forgetting to plot all my silly little points. So sorry about that. My vertex, I'm going to have to estimate where that is. Negative 12.5. My x-intercept is negative 4 and 1. When I plot my x-intercept, they should be equidistant from my line of symmetry. If they're not, I'm wrong. So I need to double check that. And I really should do that before I move on to the end. I was just getting involved in all my math. And they are, so I'm good. My y-intercept at negative 8. Reflect that point. So now I've got my 5 points. I have a bad looking U. Oh, bad U. There we go. It's a little better. It's still kind of pointy. And I'm good. My range, the set of y, such that y, my value for my vertex, everything above it is graphed, so it's greater than or equal to that value. All right, the next one on our graph is already given for us. We're just going to identify the bits and pieces. So here, my axis of symmetry is right here. What is that equation? Because if you don't write it in an equation, it is wrong. So it's x equals 1. It has to be written in an equation. My vertex right here is at 1, negative 4. Because it's a u that goes upward, it's minimum. It's a happy face. My x-intercept is at negative 1 and 3. They are ordered pairs, which means my zeros are negative 1 and 3, and my roots are negative 1 and 3. My y-intercept, where does it cross my y-axis? At negative 3. My domain. Now my range. Perfect. Now we see this extra little equate thing out to the side that says, what are the factors of the graph? All right, the factors of the graph is what equation made this graph happen, because there's no equation attached to my graph if you notice. To find out the factors of my graph, I need to see what made my solution. My solution is my roots. So I need to work backwards from my roots. My roots say that x was -1 and x is 3. To work backwards from that, well, what did I do to get -1 on the side? Well, this would have had to been a +1 equaling 0. This would have had to be an x minus 3 equaling 0. These are my factors that came together to make each equal to 0. Let me go over that one more time. Work backwards from your answer. That is my answer. So x equals both of those things. How did I come up with them? Each had to be equal to 0, so I had to bring the x over to this side. To get -1, it had to be a +1. To get +3, it had to be a -3. The two pieces that equaled 0 made the factors of the equation. Now to come up with my equation, all I need to do is FOIL the factors I just found. And then just set it equal to y or 0 or whatever. So to find the equation, all I have to do is factor what I already know. All right, last but not least today, we're going to talk about a parent graph. What a parent graph is the simplest form of the graph that there is. It's just y equals x squared. It's kind of like just saying y equals x for a linear equation. It's just the simplest of the graph. So we want to talk about how to compare the one we have here with our parent graph. So we want to ask ourselves, how does this compare to this? Now, if I had a calculator, I could calculate it out for you, but there are certain things that are things you just need to know. So I'm going to go ahead and just give them to you on here. In class, we would go over and explore them. My axis of symmetry is derived from my middle term, the bx term. So if I have a middle term, that means my axis of symmetry had shifted from my original equation to my new equation. The vertex is the c in the equation. So for my vertex, if I have a c added or subtracted on, it means my vertex either shifted up or shifted down from where it originally was, because y equals x squared means that it's x squared plus 0. So it either shifted up or shifted down depending if I had adding or subtracting a number. Max or min, we know that max is a -a, where min is a +a in our equation. Wide or narrow has to do the coefficient on a. For our equation to be wider, it's going to sound weird, our a is a fraction. For it to be narrow, a is a whole number. It's kind of backwards than what you would think. So now, looking here at our graph, we have y equals x squared plus 4. We want to know how it's going to compare. So first, axis of symmetry. That's the bx term. So with my bx term, here I don't have one, so it's exactly the same. With my vertex, here I added 4, where here I added 0, so it moves up 4 units. Again, sorry, because the announcements came on. It moved up 4 units because in my original equation it's plus 0, because that's what that would be there. So it moved up 4 units because the vertex is the c in the equation. We know here that our coefficient on a in front of our x squared is positive, so I'm going to have a minimum. So the other one's a minimum as well, so it's the same. Graph is a minimum. Is it wide or narrow? My thing right here is a 1. So because my other one is a 1, it's the same. Because here I had a 1 and here I have a 1. They're exactly the same. On the second part of your homework in the workbook, it's going to go over these same things. So let's look at number 5. All right, so what do we know? Our axis of symmetry is the same. Y, no middle term. There's no bx in that thing, in that equation. My vertex has to do with what's going on here, so it shifts down 4 units. Is it a max or a min? It's the same because they're both going to be a minimum. Is it wide or narrow? Well, there's a 1 there and there's a 1 there, so the width is the same. Only thing that graph did differently from my parent graph is -4. Because you're looking at the equation. I know it sounds weird, but you're looking at the equation y equals x squared and y equals x squared minus 4. So what's different? This one just went down 4. All right, so then looking at this one right here, we're going to compare it. I think I like writing it out. So we're going to compare it to y equals x squared. All right, so first, for the axis of symmetry, is there any middle term? No, so it's got the same axis of symmetry. For the vertex, this one has +0, this one has +0, so my vertex is the same. They're both a minimum. Now, this one's got a 4 and this one's got a 1. So remember we said with the width that if it was a whole number, it was going to be narrow. So it actually is the backwards. You think a whole number would be bigger? It's not. It's the opposite. So it's going to be narrow. So if I graphed my graph, he'd be really skinny because of the 4. Okay, let's look at number 7. Okay, again, I'm comparing this to this. And on your quiz and on your test, you're going to have to write 3 comparisons. Axis of symmetry, vertex, max or min, width. 4 things. So axis of symmetry is the same because there's no middle term. Vertex is the same because both added 0, so it is the same. Again, they're both a minimum because they're both positive. And then here my width is going to actually be wide. When I have this fraction where this just has the number 1, now my width is actually the opposite of what you think. It gets really big, so he gets much wider in that graph. And if we were in class, we'd show you on the calculator how those change so you can actually see them. All right, number 8. Number 8, we're comparing it to the graph here. So, again, no middle term. Axis of symmetry the same. The vertex, they're both adding 0, so it is the same. It's the constant. Now we're looking at whether it's a max or min. This one is negative, this one is positive, so this is a max for this graph. So max changed from minimum. And then my width, they're both still whole numbers even though it's positive and negative, so it's still the same. The only thing the negative tells me is whether he's going to be a max or a min. And last but not least, because I'm running out of time, the axis of symmetry for my last one, this one shifts. Why? Because I've got this -5. And it actually shifts, I believe it shifts over in the negative direction 5. And then the vertex here is going to make it go up, so it's going to look diagonal when we graph it. So our vertex compared to the y equals x squared plus 0. The vertex here is actually going to go up 2 units. I have a minimum for both. And then the width is going to be the same. And I know I kind of went over this quickly, but you really just need to know how you're looking at the different things. When we look at our axis of symmetry, we're looking at the middle term bx. If it changes, then it changes. It's the middle term. With the vertex, we're looking at the c term. Sorry, the c term is going to tell us if it's +2, it went up 2. If it's -2, it went down 2. We're always going to compare a max versus a minimum. And then we're going to always look at the width. And remember with the width, the a, if it's a fraction, it's going to be, if it's a fraction, sorry, it's going to be wide. And if a is a whole number, it's going to be narrow. That's the key to what we're looking at. Those 4 things. So in your homework, those should be 4 things that you list. Axis symmetry, vertex, max or min, width. Axis symmetry, vertex, max or min, width. And it's just saying, how does it compare to the original graph? Thank you for hanging with me so long. I know it was kind of long, but thank you so much.